Good morning. Today, my name is Divya. I'm going to say about the highway alignment of food store. In this, before going to topic, we already discussed about the characteristics of routes and classifications of the routes. We have different classifications. You can say as national highway, state highway, major district roads, and other district roads and village roads. All these are categorized and different purpose. And we have now already seen about the different 3 20-year plans, 20-year plans, and that we have seen Nagpur plan, Broadway plan, and the third 20-year plan. So different how the different plans they have after the get for 20 years they have different changes in it. And we have seen about why the roads are required, requirements, necessity of the roads. Okay. So all these topics we are already covered. Today in this we are going to cover about the highway alignment. So first, alignment. What it means alignment. Alignment is nothing but the position or the layout of the center of the highway on the ground is called the alignment. So on the ground, uh, before alignment this we will conduct survey. In that we will lay one central line there. So that central line is fixed line. Okay, the position of the layout of the central line of the highway on the ground is called as the alignment. So the position of the central line it is called as an alignment. Alignment surveys are widely provided for safety and protection purpose of different routes and highways. So we have different routes. We have say state, district, and national highway. Like the different routes have different width, number of lanes. So like that, the overall means you have to provide the safety and protection for the of the roads. The alignment survey includes horizontal alignment, cross section angle, and vertical alignment of roads. Majorly, we are going to deal about horizontal and the vertical alignments. The purpose of alignment is alignment as most important and crucial process for the road safety. So the main purpose of providing the alignment is to provide is safety, road safety. So when the vehicle is going on, he should feel comfort when he is driving. So that is the main purpose alignment is. So different kinds of advanced and innovative techniques are used to provide the alignment survey. The alignment survey often is not carried out in an easy and quick manner. So the if you want to construct a road, it is not a easy and also not a quick manner. You cannot do it easy and it is not a quick manner. It should get a sanction from different authorities. It will take time. So it's not a easy process. A new road should be aligned very carefully as improper alignment will result in one or more of the following disadvantages. So if the alignment is not in proper way, if it is any curves, if it is any bends, if it is any ups and downs. So alignment improper alignment in result. So increase in construction cost. It increase the construction cost. It increases the maintenance cost. So if it is low, if it is very high laying area and coming to low laying area, means the construction cost will be more, and if it is done, the maintenance cost is very low because when we get this subject, we can't do it at always request to going on. So to protect maintenance should be going on. increase in the vehicle operation cost also. So if it is going very high and it is coming down, the vehicle operation will also uh, will uncomfort and also they give more cost in this accidents also. So these are the more disadvantages if the alignment is not in a proper way. So alignment should be done in a proper way. So already we have discussed. Once the road is aligned and constructed, it is not easy to change the alignment due to increase in cost of adjoining lands and constructions of costly structures by the roadside. Because once the alignment is fixed, some of the landlords have to be, we have to adopt, we have to take we have to take those lands also into the consideration. So, if and also we have any costly structures into the roadside, it should also in that also we can't. If iron is fixed, we cannot change those like alignment. So once the road alignment is fixed, it is fixed. We cannot change. It is more costlier if we want to change. So types of alignments, these are two types of there already we have discussed, horizontal alignment and the vertical alignment. So what do you mean by horizontal alignment? The operational characteristics of a roadway are directly affected by the horizontal alignment. So the designer must consider the road's terrain, traffic volume, expected capacity, and the LOS together with other safety factors in order to properly anticipate the posted speed. So the operational characteristics of a roadway are directly affected the alignment designer. The designer must consider the road's terrain, traffic volume, so horizontal alignment. The horizontal alignment, the operational characteristics of a roadway are directly affected by the horizontal alignment. The designer must consider the road's terrain, traffic volume. So, if you want to construct any roads, the road must be considered the road terrain, how it is going on, how which type of plain terrain or any hilly are there. The terrain should be shown. See, traffic volume. If it is traffic is more, it is city. So number of industries are there. So if it is agriculture area, no traffic at all. So by consideration, all those only the type of road which we are going to get is to be taken. So traffic volume is also important. Expected capacity and the LOS together with other the safety factors in order to properly anticipate the posted speed. Highways will be designed according to their anticipated postage. So the highways will be designed according to their anticipated postage. Speed has opposed to an arbitrary designed speed. So the speed should be seen that the highway designed according to their anticipated sport speeds as opposed to an arbitrary design. So speed is also major a factor and should be considered. It should also be considered because the speed limit is also important. Anticipation, arbitrary design in speed is also important. How much we are, nothing but a traffic you can say. Next comes to vertical alignment. Road roadway vertical alignment is controlled by design speed, topography, traffic volumes, and composition highway functional classification, safety, site distance, typical sections, cross-sectional alignment, climate, vertical clearance, drainage, economics, and aesthetics. When a highway is located where environmental resources exist, the vertical alignment should be designed to minimize impacts. So vertical alignment is coming. So it should uh, vertical alignment consists of topography, and the design speed is most important. And the traffic volume and highway functional classifications, safety. So side distance, how much the brake is applied, how much distance it should be, um, it should be stopped. Typical sections. Okay, so horizontal alignment is also considered in the vertical alignment, and also the climatic conditions is also important. So all this to be considered in the vertical alignment. So vertical alignment should be properly coordinated with the natural topographic available right of way, utilities, roadside development, and natural man-made drainage patterns. So vertical alignment is typical comparative to the horizontal alignment. So we should see all these categories. Then only we can go for the vertical alignment. So requirements of a highway. So an iron alignment must have the following requirements. So what is the first thing? The road should be safe. Okay, the road should be safe, and it should be easy to drive. Okay, and should be short. So it should not take more time when we are going by road. At the same time, it should be economical in construction, and it should be comfort. So all these are requirements for the alignment. So safe, easy, short, economical, and comfort. These are the major requirements when you are doing a alignment. These are the things you have to require and you have to do when you are doing a road construction. So what do you mean safe? The alignment need to be safe during the construction, operation and maintenance, especially if slopes, embankments and cutting. So uh, during construction, any operational and maintenance, especially at slopes, okay, where at hilly areas we are considering this, there the slope will be more. Okay, so at valley, for example, if you are taking the valley position, then slopes will be more. So embankment and cutting should be we have to think how equal balance should be there. Embankment and cutting should be balanced. If it is not there, we have to get the material from other place, and transportation is required for fill. So easy, the construction materials if present at the place of construction site makes the construction easier. Similarly, it should be easy during the operation of vehicles, easy gradients and the curves. So, in the material transportation also, we have to see that the vehicle should move easily without any gradients and the curves. So then it will be so easy, and that can also be the work can also be completed within the time, and it should be short. The distance between the initial and the final point need to be short, has to reduce the construction cost. So economical, the alignment should be economical during construction operation and maintenance. However, if the construction turned out to be economical, the gradient must not be easy, which in turn increases the cost of operation and maintenance. Similarly, if the vehicle operation is taken under consideration and is made economical, the construction cost becomes higher as the gradient and curves need to be easy. So, if you want the transportation easy, then it will increase the uh, cost cost of higher becomes higher as the gradient and curves do need to be easy. So if we have to see that should be economical during the construction, operation and maintenance. We already seen that safe and short should be there, economical. So all these we have seen already. Safe, easy, short. So these are the things we have to remember. So the alignment should be economical during construction. It turned out to be economical if the gradient may not be easy, which in terms of if the gradient already we have seen that the uh, cutting and filling where we are seeing that if the gradient is going on increasing, so it turns the cost of operation and maintenance cost will be more. So economical, okay, uneconomical it becomes. So similarly, if the vehicle operation is taken under consideration as made economical, the construction cost becomes higher as the gradient and curves need to be easy. So wherever the thing we have to consider that gradient should not be more. It should be as much as possible in a straight line itself. Then only the cost and operation and maintenance will be economical. So next comes to comfort. The alignment should be fixed such that it provides comfort to the drivers and the passengers. So whoever the passenger is going to by road, he should feel comfort to the should feel comfort to the drivers at the time of driving. So there are number of factors which are to be considered while selecting the alignment of the roads. These factors are also vary according to the types of roads and the areas through which those road pass. So the factors which we are seeing is minimum requirements. So the factors may also vary from types of roads. If it is highways, then it will be different, and if it is village road, then it will be different. So types of roads and the areas, these roads also the requirements may vary. So generally this is the you can see here the dotted line, that is the alignment of the road. So we generally, if any hilly area, then what we have to do that route have to be get diverted. You can see there it is not in the straight line, it is taking some turn, it's like a bend. Okay, if it is any bridge, if any river, then it should have um, to change the direction at the time, to change that on the bridge where it is coming. So it like that we have to change the direction according to the requirements, and we have to see it should be economical and also safe when we are driving. So first, the factors which controlling the alignment of roads in plain areas. So what are the factors are controlling when we are going through plain areas? First one is the class and the purpose. So the alignment of the road may be decided keeping in mind the class and purpose of the route. National and the state highway between two stations should be aligned as straight as possible, whereas in the case of other types of roads, deviation may be permitted where found necessary. So if it is high, when it is the when the road is connecting between the highway and the national state highways, okay, in between the national and the state highways, is maximum we have to drive that there should be not any deviation. It should be straight itself. Then only the vehicle can move easily and comfort to the drivers. Okay, maximum the in between the two stations should be aligned as straight as possible. Where in the case of other types, so your other types means you can say other district roads and also major district roads and the village roads, that may be possible of getting uh, t- uh, mm, getting has a bends, you can say, okay, has any changes of deviation there, it can be permitted. For first clause is that one. Next one is the obligatory points. So the roads are basically constructed for the development of the areas. Their alignment should necessarily pass through important towns, groups of villages, and places of religious, social, political, and commercial importance. So the roads are basically constructed for the development of the areas. are basically why the roads are came for the development purposes. Right? So if the road is there, then automatically the development is also there. So the basic requirements is to come mm, is the fulfill the requirement of every of the country. So the alignment should necessarily pass through important towns, groups of people, villages, and places of religious, social, political, and commercial importance. So the road, which is the uh, mm, it should connect to all the towns of and it should connect all the villages also, and it should connect where the religious places are there, religious places where that and it should connect all the political, so then only the road get so all these will be connected in the district roads. Other district roads is majorly all these points will be connected. And next comes to type of vehicular traffic. So in the play, if we want to align in the plain areas, so these are the points what we are to see. First one is the class and the purpose. So if we are constructing for the national highways or if we are constructing for the district roads, the purpose is important. So the width of the road is important, and any it should be strained for the national highways. We have to remember that no deviation should be done. And if it is for the obligation, if it is for the district roads, then obligation points are requirements, all the obligated points are to be connected to that one. Next comes to types of vehicular traffic. So the alignment should be provided according to the type of vehicular traffic. In case of fast moving traffic, the road alignment should be straight as possible, where as in the case of bullock carts and tangas, nowadays we are not using. If we are using any bikes, okay, so the alignment side bicycles, you can say the alignment may even have shortens. So if we are using for the highways, then there should be straight as possible. Where we are using in the district roads, any bends, sharp bends also, we can, if if it is not possible to deviate, then we can put there the possibility of keeping of shortbands at that location. So we have to see the importance where we are giving the road to that area. So that is important. Next comes to gradient. Here before we have seen the terminology is the gradient. So what do you mean by gradient? The alignment of road should be selected so that longitudinal slope are not steeper than the ruling gradient. So longitudinally, okay, longitudinally, and the ruling gradient, you can say if in that see you imagine that one triangle figure, okay, and the hypotenuse is, if a hypotenuse going on increasing, so then what it means, the vehicle which is pausing to that one longitudinally it is going on, the length is going on, okay, and hypotenuse is going on to increasing, means the opposite distance which is going is also we are increasing the, if we are decreasing the base and we are increasing the hypotenuse, means the opposite distance which we are going, the vehicle is increasing the height. So there we have to see the length and the hypotenuse should be similarly, it should easy, so that the angle which is coming, okay, the opposite thing, the angle which is coming, it should be not steeper, should not be not steeper. So that is the ruling gradient method. So there we have to see that the alignment should be not steeper, so it should be easy to go. To achieve this, the alignment might need a deviation from a straight line gradient, where if there is no chance of getting for a straight line, then we can provide a deviation from the straight line, but the gradient should not be more steeper than the Rulian gradient. Rulian gradient, which is comfort. having a less angle. There we can, this gradient we can be provided. Next comes to horizontal curves. Horizontal curves is nothing but the alignment of roads should be provided with the flat curves wherever found necessary. In case of national and state highway, the radius of curvature curve should not be less than 230 meters. So in order to have a minimum radius, the alignment must be changed. So the alignment, if there is have to be kept in the in case of highways, then there we have to provide not less than 230 meters of radius. Okay, the curvature of radius, you can say, it should not be less than 230. Radius should not be less than the 230 meters. In order to have a minimum radius, alignment must be changed. If we want any we have to provide any there is no chance of getting 230 meters. If you want to change, then we can go in different alignment having the minimum radius in order to have a change. So should not be less than 230. First we have to remember for the horizontal curve. So if it is for the vertical curve, it should be less, but we have to change the alignment to that location. So next comes to sight distance. So the alignment of road should be decided such that minimum sight distance is available for drivers of the vehicles. So the visibility of the uh, person should be so that if the brake is applied, the minimum distance should be there, vehicle and from one vehicle to other vehicle, that should be, we have to design minimum side distance is designed. So how it will be, if the road is so smooth, if it is not in the control, then what it will, if the friction will not be developed and the person will not able to make a break sudden. I mean to say, if he makes also, it will not stop. So that the distance, the road should it be so that the minimal side distance is also maintained. Like that, we have to decide. Next comes to obstructions. So the alignment of roads is decided keeping in mind the obstruction. For example, the alignment should be changed to avoid the marshy land. So if there is any agriculture area, if there is any marshy land and any graveyards and any historical monuments are there, so the straight road is not possible at that point. There we have to change the road. So historical at that the deviation is accepted. Next comes to cross drainage works. So any bridges, you can say, the alignment should be adjusted so that the minimum number of cross drainage work should are required. So when we are laying a roads, minimum cross sections to be done. If it is more, then it is uneconomical. So maximum we have to try to avoid to do those areas where the low laying areas are there, where the rivers are, where the canals are, any water resources are getting interrupted. Those areas should be maximum avoided. If we are laying means we have to lay the bridges, or after only we have to construct the road. So to achieve this, the alignment should be chosen along the watershed line if possible. Next comes to bridges. So while crossing river, the site should provide all the requirements needed for a good bridge construction. The alignment of the road should cross the river at 90 degrees to avoid the construction of the bridge. So the site should provide all the requirements for a good bridge. The alignment should cross the road at 90 degrees only. So, okay, to avoid any screw bridge. Next, railway crossings. A road um, alignment should across a railway, preferably at 90 degrees only. Formation bed. The selected alignment should be through such areas which provide good formation bed. Next, earthwork. To avoid the excessive cutting and filling, the alignment should be changed where found necessary. So, cutting and filling should not be there for a road work. There we have to say. Next comes to last agriculture. So agricultural land and dense forests. So we have to maximum avoid the agricultural areas only. Okay. So the agriculture of road should be decided so that costly agricultural land and defense sorry and dense forests are avoided. So for the acquisition, okay, of the land, so there is a chances of acquisition and land cost will be more at that areas. Those acquisition problem will come. So we have to maximum try to avoid those areas also. Next comes to existing right of way. In case of upgrading a road, its existing right of way should be utilized for curtailing the cost of land acquisition. So land acquisition problems will come. So we have to see, we have to upgrade a road, its existing road. So already we have put a road of 3.5 meters, and it should upgrade a road. There, utilizing for the curtailing the cost of land acquisition problem will come. So we have to see before itself if there is uh, land with land width will be, we have to side we have to provide a more space, then there will be not any land acquisition problems in future expansion also. Public demand. The selected alignment of the road should meet the public demand of the area. So these are the about the plain areas. We have seen 15 factors affecting the alignment. So these are the alignments where we have seen. First, we have seen the um, we have seen the uh, class and purpose. Okay, where it is a national highway or state highway, maximum should be possible has a straight in between those two stations. And next comes to obligatory points. So obligatory maximum, it should connect all the villages and also all religious places and political where it is there, that alignment should connect. Next comes to types of vehicular traffic. So on the traffic only we can decide the alignment which type of either it is a highway or it is a uh, state state. So it should any sharp bends are to become. If it any sharp bends are coming, then we will go for the other district roads, or either that we have to avoid those places. Next comes to gradient. Gradient is also not the maximum we have to consider. If it is considered that gradient should not be steeper than the ruler gradient. Next comes to horizontal curves. If it is we are providing for the national highways, then the radius should not be less than 230 meters. If it is there, that alignment should be changed. Okay. And next the side distance. So the side distance should be available for the drivers so that they can decide the minimum distance for a vehicle. So next comes to obstructions. If there is any dense forest or any graveyards, then they have to change the alignment. I am keeping in when we are like the alignment itself, we have to see, we have to keep minimum cross drainage walls, and we have to keep, if there is any bridges are there, we have to provide that alignment in 90 degrees only. In the case of railway crossings also, we have to provide the 90 degrees. And the formation bed should be strong so that the cost of the alignment is also get less. So the if the formation bed is strong, then it will be cost will be economical. And we have to maximum avoid the cutting and filling, so that we can have the alignment should be changed where found necessary. More cutting and more filling is that we have to maximum avoid to those places, and we should also avoid the agricultural land and dense forest so that the land acquisition problems will not take place. And also we have to see the existing right of way. The already road is existed out there. If any upgrading is coming to that road, then also there is a cost of acquisition will be both. So in future expansion we have to leave the roadside for a future expansion also. Instead of having a minimum width, we can provide this much of in future it might be getting this as a state highway, or this chances of getting of national highway. Like that we have to at the time of survey we decide, and we have to prolong the a length width at this at the future expansion. Next comes to public demand. The selected alignment of the road should meet the public demand of the area. So those are the things. Next comes to factors affecting the hill road alignments. So hilly roads, the main factors to be considered in the alignment of hilly roads are, first one is the length. So the cost of construction of a hill road per kilometer length is comparatively very high compared to the plain areas. So if we are constructing the plain area, so it have less cost compared to the laying at the hilly areas. So it should therefore be ensured that length of the road connecting two stations should be minimum possible, adopting the ruling gradient along its most of the length. So we have to see that ruling gradient should be maintained overall the road. So if it is connecting between two stations, the ruling gradient should be minimum and should be like that. It's almost we are seeing as the road is so straight itself. So it's maintaining the ruling gradient. A gradient, a proper gradient is maintaining. It is not going like this up. We are seeing as a straight. So ruling gradient maintaining is typical in the hill roads. So next comes to altitude of the road. At lower altitudes, large number of cross drainage works are required to be constructed. So whereas at higher altitudes, the road pavement may witness snowfall during the winter. So that is why the alignment of hill road should preferably avoided at an altitude between 900 meters slope exposed to sun. So we cannot construct on low altitude also. If it is we are constructing very lower levels, then there is a possibility of getting of a cross drainage works. If it is going for the higher altitude, then there is a chances of getting of snowfall. So there we have to maintain that altitude in between the 900. So slope, that length or that height, we have to maintain to the slope of exposure to sun, where the sun is exposed is that is important. The hill slopes, which are subjected to high winds, should never be selected unless until there is no other alternative. In north, sorry, northern hemisphere and southern slopes of the hills are more suitable than northern slopes, so which remains tin shades and are usually subjected to high winds. So in northern and southern slopes of the hills are more suitable than the northern slopes. Because northern hemisphere, in the northern hemisphere, we are taking the southern slopes. We are more suitable. Then we are taking for the northern slopes, because in the northern slopes, if we are take there is a high winds are there. So we have to provide in the south slopes. So slope should be in the south side, so that wind which is coming on the hilly areas, it can be controlled, and should be controlled in that area. So if you are going more if you are going on higher altitude, I mean to say higher, if you are increasing our height, if you are going at the top of the hill, there is a chance of rain or water, drainage water. If it is in the rainy area, there is a chance of getting of snow in the winter season. And if it is wind is there, then there is also a problem. There is a more wind, because in the hilly area it is completely open. No buildings will be there, so it is completely, the hill is open to the atmosphere, so there will be more. So there is a problem, so we have to see all those. Next comes to saddles. So saddles are passes. So while locating the contour gradient of the proposed alignment of a hill road or a counter map, it should cross the ranges through saddles. So though the length of the road is increased, the heavy cost of cutting through rocks is avoided due to increased length. Ruling gradients can be suitably adjusted. So saddles or passes are nothing but the contour map. You can see where you can in the any mm, in the proposed element, contour map should be, so before uh, going to the hilly area, we have to see the contour map before going to that. So it should cross the ranges through saddles. So in the contour map we can see saddles, valleys you can see. Okay, though the length of the road is increased, the heavy cost of cutting through rocks is avoided. So due to increased length, ruling gradient can be suitably um, adjusted. So before going to the construction, we have to see, before going to the survey, we have to see the contour maps itself. Then we get an idea how to go to the next comes to stability. So stability. Stability of hill slope. So while deciding the alignment of hill roads, it should be ensured that the slope are stable. Okay, the slope of hilly area should be stable. Should not be ensured that the slopes are stable or not very steep. So here we can see that the slopes should be stable and should not very steep. So at the time of construction, we have to see the stability of the hill roads. So it is strong or not. If it is not strong, then there is a chances of getting fall from that place. And capacity of the soil should be seen whether it is having that much of capacity or not. The area is not prone to landslides and settlements. So this factor is a special importance in hilly areas where having sedimentary rocks. Okay, if there is a that hill is a form of sedimentary rocks, then we have to see the capacity of soil capacity or stability of the hill road, because there is a chances of getting of settlement for years, and there is a chances of getting of landslides also. So we have to check whether we have that road is perfectly fit or not. So next comes to geological structure. Cutting through the solid hard rock is very expensive. The alignment of roads may be suitable. They deviated to avoid the such areas. So in the geological structures, we have to see whether the solid hard rock is very expensive, or in cutting it, if in cutting it will take more time. So we have to see whether it is suitable for cutting, and for stability we have to see. And solid hard rock is cutting, we have to use very yeah, expensive machinery. So we have to see whether it is useful or not. So the alignment of road may be suitable deviated to avoid such areas. So the alignment of those cutting hard rock, expensive cutting of hard rock should be avoided. Next comes to tunnels. So drilling of tunnels is very expensive. The road tunnel needed ventilation as well as lighting arrangements as far as possible. Tunnels should be avoided under resorted to only if other suitable alternatives not feasible. For example, we have seen in the Vijayawada, anyone have gone. So we are passing under the tunnels. So there is no alternative in the hilly area that should be going through that. Through the tunnel itself, so no alternative. So they have kept the tunnel. So in the tunnel, we have to see that ventilation should be there. So it's, lighting should be there. So both are important, ventilation and the lighting. So as far as possible, tunnel should be avoided because it resorted is more. And other, if there is no other suitable alternative, then only we have to go for the tunnels. Next comes to valleys. While deciding the alignment for roads for crossing a river valley, due to construction should be given to avoid the construction of number of bridges of its on its attributes. So in the hilly areas, when we are making the alignment, we should avoid river valleys. If there is a river valley, we have to keep the bridge. So maximum we have to avoid the number of bridges for the construction. Next comes to um, geometric standards. Geometric standards are nothing but alignment of the hill road should be selected on the hill slope, which easily provides the recommended geometric standards, that is gradient. Okay, that is the gradient curves, sight distance, etc. Okay, hairpins, bends. So in the alignment of the road alignment, so the hairpin bends we should maximum avoid. So if the bends are there, sharp bends are there, the road, the vehicle may get off from the curve. So because of because of super elevation at that position. So that super elevation hairpin should be on the road should be avoided if found necessary. These there should be on gentle and stable slope. So if there is, if we have to provide, then it should be provided on a gentle slope. And to have a proper geometric standard should might be necessary to change the alignment at number of places. So geometric standards change the alignment at number of places. Next comes to camping sites. So if at intermittent distance, the alignment of the hill road should pass through a gentle slopes where suitable comply sites should would be developed for military personnel in case of necessity. So these gentle slopes are to be provided where the military or any military areas or any personnel in case of necessity. So their complying sites are to be provided. Interpreted. So this is about this one. So here we have discussed all these. We have discussed about okay. So this is where we can see maximum we have to provide according to the ruling radius. We cannot go very high so that there is a uncomfort in that. In and this here we grade and cards we have to see any changes in that. uh, so if there is any changes then we have to see the any changes in that uncomfort will be there for the vehicle who is driving in that. We have to see the stability of the ground. So stability also we have to check. And if there is any settlement or already already settled ground, you can say sedimentation grounds, There we have to see there is a chances of getting of uh, getting of away from the alignment. So there we have to see. Next comes to hill cutting, hill road in cutting and filling. Okay, in cutting and filling. Next comes to component parts of the sheet. Here we have seen the cross sections. The section in cutting and filling we have seen say a hill road. Here we are seeing. So it's a cutting here. It is cutting and it is here. It is filling. Next comes to the components of hill roads. So first one is a road bed. Next comes to side drain, parapet drain, catch, water drains, breast wall, retaining wall, and cross drainage walls. So in the road bed, we have seen the pavement portion of the hill road is called as an road bed. So what is the function of that one? To resist the stress developed due to moving of traffic. This is the road. You can see here it is a road bed. Here it is a road bed. So what is the function? Hill road is called a road bed to resist the stresses developed due to the traffic. So next comes to side drains. Side drains is provided on the sides of the road. It is called as a side drain. So it will drain off the water. Side drains run parallel to the length of the road. So main function to collect the rainwater from the camber or on the roadway, you can say. Next comes to parapet wall. So the wall is provided about the formation level. So in the downside, the slope is called as an parapet wall. So the sides of the road, if you see above the formation level, okay, on the carriageway, hmm, on the camber at the side formation level, a parapet wall is provided because the main function is to protect from against from the traffic, okay, and it will helps you down the hill slope. So if any water from the topmost, if it is coming, it will it will stop at that level, so that the slope will not get away from the drain off from that area. And next comes to catch water drains. It is drain water provided on the higher slope. So it is also run parallel to the road, and its main function is to run off coming from the top of the hillway and divert water into a nearby cross drain. So cash drain is what it will collect more number of water when it is in the rainy season. The water which is coming from the top of the hill, that will be collected in the drainage water, and it will send to nearby any cross drainage works are there. Next comes to breast wall. It's nothing but the wall constructed to upside slopes. Is called as a retaining wall. So main function is to protect from the sliding up and also side slope retaining walls. So it will protect the side slopes of the component. It will protect the slopes which is coming from the uh, uh, s- the top of the retaining wall. So the main function is to protect the road from sliding up the side slopes. Next comes to west wall is to side upside slope, just like a retaining wall. So how it will protect the from on the hill, on the topmost of the hill, some amount of getting of falling from the higher outside. If there is in some cases the rocks will come, some sand will come, some soil will come, like the some all will fall from higher. So it will protect, it will act as a retaining wall, you can say. The wall constructed to downside slope of a road is called as a retaining wall to protect downslope. Okay, sliding. It will protect from the sliding. Next comes to the cross drainage works. So the drains which is laid along the width of the road is called as a cross drainage works. So main function is to drain of the rainwater collected in side drains. Okay, the main purpose of this one is to drain the cross drainage works which is coming to the which is coming from the side drain. So main function is to drain the rainwater collected in the side drain. So main what is the main function is when the drain which is laid along the width of the road it is a side, you can say here, not parallel along the road, it is a width, along width of the road it is good. Here before we have seen the drainage, there it is going parallel to the length of the road. Here it is with the road. So main function is to drain off the water collected in the side drains and catch drains. Next comes to, so what is the, here we have all the same, we have the components of the roads for the hill roads. So breast wall, retaining wall, and cross drainage walls, and catch drainage walls, and the carriageway. So all those we have seen. So what is the actually need of cutting and filling? So the construction of hill roads may be partly in cutting and partly in abatement. To intercept rainwater from the hill slope, catch drainage waters are constructed. So here this is a summary of the what we have seen. So the hill slope catch drains are required. So they are constructed parallel to the roadway. So water from the catch drains flows by gravity up to cross drainages. So we have how we have to design that water should flow by the gravity, okay, by the gravity up to cross drainage structures like culverts or bridges any nearby, and passing below it, it could cross the road, and we have to design that it should pass the road safely. So here in this we have studied about the topics of topics what we have seen today. The topics are about the alignment is nothing but a center line which is passing throughout the length of the road to uh, to uh, to have a why the alignment should be provided, should have safe and comfort, okay, easy easy, and the gradient should be, we have to see. Now what do you mean by the gradient? The gradient should be reach the ruling gradient, it should not be more the ruling gradient. If it is more, then there is a chance we have to deviate that deviation line, alignment. We have to deviate this gradient if it is not satisfying the minimum ruling gradient. So the and factors affecting the uh, alignment are for the plain areas and the hilly areas. We have to see in the plain areas it should uh, maximum pass straight lines in between the highway and the state highways, and should maximum should connect to the obligated points, and it should should uh, satisfy the public demands, and we should avoid the historical plains, and we should avoid agricultural land, we should avoid the dense forest. If it is have to provide the change of gradient, then the gradient should satisfy the ruling gradient, and it should not have more for the highways, it should not have any curves, if it is provided, it should be less than it should be more than 230 meters. The radiant should be there. So all the things we have to, all the points are factors have to be considered, but the plain areas. Next, for the hill areas, we have to see that should not have more steeper and should not have more cutting, and more cross drainage should not be there, and the stability we have to see the stability of the ground, and any uh, changes and sharp bends should not be there, and it should also maintain the ruling gradient. The ruling gradient, it should not be, and we have to see the uh, s- uh, uh, it should not be more steep. Steep should not be there. So all the component parts we have seen already press, carriageway or the um, carriageway, and also drainage catchment, uh, catch catchment areas, and we have seen the retaining walls. Okay, all this we have seen, and at the same time the importance of the hill road in cutting and filling, all this we have seen today this topic. So these are the summary of this topics.